Hello, everyone. Welcome to another session on Agentic AI or Python using Agentic AI. So today we'll discuss about essential frameworks and design patterns. So in this module or in this session today, so we will look into simple Python scripts for agentic design patterns, and these are the standardized algorithms used to give LLMs a structured way to think. Okay. Now, if we talk about the ReAct algorithm, or which roughly translates to reasoning and acting. Okay, so this is the most fundamental algorithm in agentic AI, and it forces the LLM to write down its own thought before executing an action. Okay, and yeah, so before executing an action. Okay, now start the slide. Okay. Now, when you talk about the React flow, so basically the React algorithm flow. So, first, what we have is a question, which is basically kind of a users or of an user's goal. Okay, and then we have thought. Okay, the thought is basically the LLM that describes what it needs to do, and then we have the action where the LLM selects a tool to call, and then observation, where the output of that tool, normally the perception, and then repeat. So the LLM looks at the observation and starts a new thought. Okay. And why it's an algorithm? So basically, it prevents the LLM from blabbering, and it also forces it to follow a logical state machine. Okay. Now, why basically, I mean, why it matters? Okay, so it matters basically. It forces explicit reasoning for before action. It also, if you have a lot of hallucination, it can reduce hallucination and error propagations. It improves human interpretability, and then creates task solving trajectories, and then it also helps you in overcoming knowledge cutoff limitations. Okay. Now, let's understand retrieval augmented generation, or RAG. Okay. So, agents often don't know the facts they need, right? So, RAG is basically the algorithm that is used to give the agent a library card. Okay. Now, what basically it does? So, the the problem RAG solves is like knowledge cutoff, specific domain data that is not particularly in training, company internal documents, or even, if you want real-time market data, that also it can provide. Okay. Now, if we want to understand what is within the rack, what is, I mean, the very first component, which is vector search algorithm, or you can also call it as similarity search. Okay, so instead of searching for exact words like Google used to do in early versions of Google, like in the 90s, late 90s, early 2000s. So basically, they whatever keywords you used to provide, it used to try to find out only those keywords. Okay. So in vector search algorithm, so basically, if you try to understand the process, it converts text into long list number of I mean long list number of I mean long list numbers, basically, or what we call it as vectors. Like, it uses cosine similarity, which is like a math formula, to find which documents are mathematically close to the user's question, but that all goes at the back end. So you just have to understand the engineering part of it, like what it does, what output it does. The backend maths, yes, you can that is always in scope. So if you have a good knowledge what happens at the backend, So definitely you can search more or look into more details how it does, like what exactly is cosine similarity and what is the maths behind it. So you're free to do that, but that is not in our scope or in for this particular session. Maybe in some other sessions or in other some other videos, I'll also try to explain that. Okay. And it also helps in returning most relevant results like semantically. Okay. Now, um, just to give you a small introduction about cosine similarity. So basically, it in this the direction matters, not length. Okay, so it basically compares angle between two vectors. Score ranges since cosine like 0 to 1. So the higher the value, the more similar the or the more accuracy is between the vectors, and it is very I mean, it is a perfect tool for comparing embeddings, and it has very good computational efficiency. Okay. Now, if we go ahead and discuss about what is the difference between standard RAG and agentic RAG. Okay. So if we talk about retrieval augmented generation or RAGs, so I mean standard RAGs. So basically, standard RAGs are they always retrieve data before answering, whereas when it comes to agentic RAG, the agent decides if it needs to look something up. Okay, if the user says hi, the agent skips the search. Okay, and if the user asks like what was the cost of a particular item in the year maybe 1995, the agent chooses I mean with that question the agent will choose to trigger the RAG algorithm. Okay. Now if you look at the exact points or exact difference, so basically when it comes to standard RAG, it is very fixed retrieval process. So whatever input you provide, you'll get an output. Okay, but agentic RAG doesn't do that. So even if you're providing some input, it will decide whether it has to search or it will skip search, or if it's a very simple query where search is needed or not. So it will decide that, and then it will take the action. Okay. And standard RAG as the process, it's very inefficient, and whereas when it comes to agentic RAG, it's more efficient, and it is more intelligent or intelligence based. Okay. Now if we talk about RAG in action for a particular, a particular example, like I gave like a price of a particular stock, like Apple revenue query. Okay. So if the user provides what was Apple's revenue in 2024, so what will happen? So basically, so the query is identified as the vector embedding, and then the search vector database for financial docs. Then you have then it will basically retrieve Apple 2024 earnings report, and the LLM basically will try to understand and understand the report and generate answer from the report or the retrieved data. Okay. Now next, we'll discuss about planning algorithms. Okay, so how to plan and execute patterns. Okay, so this is used for more complex and multi-step problem. So basically, for complex tasks, so React loop can get lost. So their plan and execute is more advanced algorithm. Okay, so if we talk about the logic, so here we have a high level we have planner, which is basically a high level LLM, and it creates a list of 5 steps to solve a big problem. And then we have executor, which is smaller, faster agent that takes step 1 and then completes it, and then you keep going over different steps. Okay. And then we have this replanner, which after step 1 is done, the planner looks at the result and updates the remaining 4 steps. Okay. And then it runs in a loop, like then you have a uh, repeat logic, and then it continues through all the steps like a loop. Okay. So to give you A simple use case is like building a software feature. Okay, you don't just start coding, just start coding from day one. Okay, so basically you plan the architecture, then you write some tests, then you write the code, then you review and refactor, right? So it's something similar. So you just don't start coding, you plan the architecture, then you write the tests, and then you start coding. Okay. Now, so if we try to find the difference between React versus plan and execute, so to give you some examples, so Reacts are basically short-term decisions, okay, and plan and execute are long-term strategies, and then Reacts are iterative problem solving, whereas a plan execute are structured executions, and immediate. So in React, you'll get immediate feedback loops, whereas in plan you'll get regular planning. Okay. And so before using the uh, vector database, so there are a few things you have to keep in mind. So you have to understand how AI compares text, how to use scikit-learn or basic maths, and then implement cosine simulator. This is optional. This, I mean, normally it's taken care by the tool itself, but yeah, it's better to understand or to have a knowledge on this, and then see how agents find relevant information. Okay. Now, the essential components that we may need or we will need. So the vector embeddings, which are basically semantic representations. Then we need a vector database, very efficient storage and retrieval database, LLM decision engine, React for React plan and execute logics, and then we will also need tool integration, which will basically call those functions. Okay. Now, yeah. So next, for today, building a RAG agent will be our next step, but not we will not today. So we will try to understand. We will not use scikit for today. We will just try to understand how basically we can use class and objects. So class basically will act as the agent blueprint, and object will be like a specific agent instance. Like for example, it could be like a financial agent or anything. Okay. So for our example today, so we will take or we will design something which will be similar to a financial agent, but we'll also try to understand this with the concept of class and objects. Okay. Now, let me also show you. It is very similar to whatever whenever you are doing loops or object oriented programming. So these are very similar concepts. So basically we define a class, and after defining a class, we create objects, and then once we create objects, we can just go ahead and print our objects or use our objects in the code. Okay. So it's we keep it I mean, we can take it as simple as that. Okay. Now, okay, so next, let's try to build it or try to see how it works. Okay, now let me create a new file. Okay, so um, now let's start with the class. I'll call it as research agent. Okay, and then we'll define. This is how basically you define arguments. So init, and then self, and then okay. Now self and model name, so these are the default default arguments or parameters that are created. Self is the default parameter. Okay, so whenever you're creating a class, within the class when you're defining it, so by default the self parameter gets created, and then the second one is basically what you created. Okay, now once you're done, so now we have to define like something like this. So self dot, okay, so this is the variable that we're creating, is equal to basically model name. Okay, and just we'll create a blank array, so that if we need to store some values within it, we can store it. Okay, and if you want to append it or something, you can do it at a later stage. But yes, for now we'll just store something in that array. But first we'll create an array which will act like a memory. Okay, so we'll use self dot, so another variable is, okay, square braces, and then again we'll define um, the function task, and then this we will print. Okay, so now, so there are two functions: init, the default one, okay, and then we have defined another function within this particular class, plan. Okay, so now I'll at a later stage I'll show you. We'll create an object, and then from that object itself, we'll pass some parameters into that class, that the one we have created, and then we'll see how we can use the object, and within that particular object, which of the method within this particular class we can call. Okay, so that I'll show. So print, this is, okay, and next is return. And finally, um, just a second. So now next we will create the agent. So you have defined the class. Within the class, we have created the function. Okay. So now we'll create an object. Okay. So I'll create my agent as the object, and then use the search agent. Okay. And then we'll pass some value. Okay. Like for example, we'll pass this parameter. Okay, so we have created this particular object. So now if I want to call that object or use that object, so I can do that. So I'll use it within a print my agent. Okay, so now in that object, so basically now since we have created a class, and then we have created an object using that particular class, now we can also utilize whatever functions are there within that particular class. We can also use it. Okay, so like for example, I'll use agent dot, so plan. Okay, so this particular method that we have defined within our class, so we can use it. Okay, so now here we will pass value, like for example, okay, so now we save it, and if I if I execute it, okay, so now I'll get the result. Um, algorithm planning steps for market analysis. So task, okay, so defined it. Task, so this is in the plan. So this is the parameter that we have defined. So this is the parameter. Now here agent plan, we are passing this parameter market analysis. So basically this market analysis value is passing here. So it's printing this, and then since there is a return, search, analyze, and report. So that's why it's also returning search, analyze, and report. So this is how basically, no, I mean, this is normally how we design agents. Okay, so this is a very small example using a class and an object. And so basically that will be it for today's session. And then we will again connect for more examples. Thank you.